Today's topic is 18FT305 Basics of Fiber, Yarn and Fabric Manufacturing, and we are at Unit 3 Yarn Manufacturing. We are at Lesson 3 and we talk about post spinning system, types and its applications. Now we have seen the ring spinning system. So we will try to see there are other methods of spinning, that is called the melt spinning and the wet spinning operations, along with the dry spinning, as we have already seen. So different spinning systems are applied for different fibers. So those kind of spinning systems will produce different types of yarn. Normally the filament yarns are getting produced from its melt spun and the wet spun yarn, and their characteristics are also different because their raw materials differs and their processing systems are also different. So those are included in the post spinning systems and how it is getting applied for different types of fibers to produce different fabrics. So spinning system plays an important role while we are producing different types of spun or filament yarn. So that will be covered in lesson 3. So post spinning operations, what do you mean? As we can see a comparative area, that is wet spinning, dry spinning and the melt spinning operations. So those are the things are covered into this system. And as you can see from the schematic views, that operations are different in different spinning systems. Let us see how it differs. Now man-made fibers are manufactured by spinning the polymer. So man-made fibers are produced from the polymeric material. Okay, so these are very common. Now let us start with the melt spinning, the polyester filament yarn, how it is getting produced. So you can see that different types of yarn, filament yarn and lustrous yarn. So those are all getting produced in the melt spinning process. So it is a typical spinning of synthetic fibers, as has been shown here: polyester, nylon and polypropylene. So those fibers, the spinning, if we want to do, you have to do it by melt spinning operations. Due to this, their properties are also different than the normal spinning material or the natural fibers. So it is a totally a man-made fiber, that's why melt spin or melt spun yarn. So how it works, let us see. Now you can see the melt spun yarn, how it is getting produced here. So feed hoppers are there, and then the extruder is there, mixture is there, then melt pump is there, spin pack, then some sort of quenching chambers, and from that it goes into different rollers and finally to the winders. This is a basic structure or schematic view of melt spinning process. So this schematic diagram, we will try to understand it little thoroughly. Now in the spinning process, what happens, as is shown here in the picture, the polymer which is there, polymer means it is a chips form. Okay, so polymer is heated, and during the heating process it melts, and after melting it forms a liquid spinning solution, and that solution is sometimes called a dope in these melt spinning operations. Now chips of polymers are fed to a hopper, as we have already seen in the previous and this photograph also, which is heated, and obviously this, when heating is done, that melting operation will be taking place, and then the molten liquid will pass through. Then the solution is purified by the operation of the filter, and molten polymer is extruded at high pressure and constant rate through a spinneret into a relatively cooler air stream, and because of that cooler air stream it solidifies the filaments. So basically this is the melt spinning process happened in the industry. Now finally what happens? Finally the filament yarn either is immediately wound onto the bobbins or further treated for certain desired characteristics or end use. Now what are the important parameters of this melt spun yarn? As you can see in a closer view how the melt spun yarn is getting produced. So requirements for melt spinning, if you see, the polymer should not be volatile, as is obvious that if polymer at a high heating conditions, if it volatiles or if it vaporizes, then ultimately one cannot produce the fiber out of it. So it should not be volatile. Then the polymer should not decompose in the molten state and the melting point. So polymer, that property should be there so that it should not decompose. And then the polymer should be 30 degrees centigrade less than its decomposition temperature. So that type of characteristics must be there in those polymer. So those are the requirements actually for melt spun yarn or melt spun process. Now what are the special feature of melt spinning? As you can see, a schematic view again, that different parts of this melt spinning is shown here. Now here first important feature is that high production, and the spinning speed is around 1000 to 2000 meters per minute. Of course there is hazard into this, okay, associated, but it is non-toxic in nature. The hazards which are associated must be improved or removed from there. No environmental pollution is there. No solvent requirement. Heat of spinning is very high. So these are different characteristics of melt spinning, advantage and disadvantages of melt spinning process. Now let us go into the dry spinning process. Now dry spinning is a typical spinning which are applied for acetate, triacetate and some acrylic, mode acrylic, spandex, vinyl, PVC or PVA fibers. So those kind of fibers cannot be melt spun or ring spun. So dry spinning process is applied to this. So these are the different fibers which can be produced to these dry spinning processes, as is shown in the figure. Now these particular kind of packages are also having different special characteristics. Now schematic diagram of dry spinning process again is shown here, as you can see these photographs. So dry spinning process is given here. Now if we try to understand what is dry spinning, then we have to go into this schematic diagram, understand that in dry spinning a volatile solvent is used to dissolve the raw materials and form a solution, okay, that is important here, and then the solution is purified by filter, and this filtered then is extruded through a spinneret into a warm air chamber where the solvent evaporates, solidifies, the fine filaments. So these are different processes involved into this dry spinning process. Finally, what happens? Finally, the filament yarn either is immediately wound onto bobbins or is further treated for certain desired characteristics or end use. So this schematic view, again, if you close look, if you do, then what are the requirements of dry spinning process? It is used for polymers that need to be dissolved in a solvent. So that is the requirement in the dry spinning process. The special features also talks about flammable solvent hazards, solvent recovery, and it works in a very slow speed, 200 to 400 yards per minute. So those are the special feature of dry spinning as is shown in the figure. Now let us come into the wet spinning process. What do we mean by wet spinning? And which fiber is covering the wet spinning? It is a typical spinning of aramide, lyocell, PVC, nylon, vinyl, viscose rayon, spandex, acrylic and mode acrylic fibers. Wet spinning process, if you can see that different very lustrous yarn is getting produced out of this as is shown in the figure. Now schematic diagram of the wet spinning process, if you can see that schematic diagram is there. By following this route, the wet spinning operation is getting carried out. Now if you go into the details of the spinning process, we can see that a non-volatile solvent is used here to convert the raw material into a solution. Now solvent is extruded through the spinneret either by simply washing it out or by a chemical reaction between the polymer solution and a reagent in the spinning bath. And after the extrusion, the solvent is removed in a liquid coagulation media. And finally, the filament yarn either is immediately wound onto bobbins or is further treated for certain desired characteristics or end use. So these are the spinning operations carried out as is shown in the figure in the wet spinning process. Now different requirements of wet spinning process, if you try to analyze, this is used for polymers that need to be dissolved in a applied to a polymers which do not melt and dissolve only in non-volatile or thermal unstable solvents. So it is a very closer view of a wet spinning process is shown here, and the requirements has been discussed. Now in the wet spinning process, the special features, what are those special features? As you can see here, large toes can be handled here. It is a slow process, 70 to 150 yards per minute. Washing is required to remove the impurities. Solvent and chemical recovery processes are also there. So now we have come into the summary of this particular lesson. As we can see the starting of post-spinning processes. In that post-spinning, we have seen the dry spinning, the process and applications. We have seen the wet spinning process, the process and applications again. And also we have seen the melt spinning, the process and applications. So we have understood that different fibers, they are having the different spinning techniques by which they are getting produced, and is shown here also in the form of dry spinning, wet spinning and melt spinning. So these are the areas, that's why we covered for different filament yarn, or synthetic and semi-synthetic fibers. Thank you.